Hello everyone, myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss the topic of authentication header. So coming to the overview of this authentication header, we need to see what is meant by authentication header and what are the format of the authentication header and how authentication is going to be work and what are there some type of mode of operations. So coming to the what is meant by authentication header, we need to know authentication header is the main purpose. So here it is one type of security protocol. So basically we use within an internet protocol security. So authentication header is always related to the internet protocol security purposes. So its main function is to ensure that the message should remains unmodified. While they are going to, during transmission purposes from the source to the destination, the main function is to remains unmodified message, so that from the source, and it also confirms the data should originate from the expected source. So it basically the output should be comes from the source. And also adding to the header to IP packets, that is internet protocol packets, it also containing mainly checksum and also the digital signature process. Basically this checksum is nothing but an errors. And also digital signature means information, some kind of information. So this header to the internet packets, basically it contains the errors and also the information in the digital signature process of the authentication header. So the mainly it contains two types of the functions. One is message integrity and second one is source authentication. Message integrity is nothing but the message should not be modified. That is called as a message integrity. The next source authentication is nothing but exactly the source from where we are getting then expecting data. That is nothing but a source authentication process. And what will happen in the authentication header if the process runs to the user A to user B, means from source to destination. So let us see here, when the packet is sent to from A to B, it consists of the whole data and it consists of the packet information. So already we have discussed in the previous slide, that is by headering to IP packets. IP packets is nothing but it contains of packet information, whether it is some message or some kind of data. So this authentication header, after sending from source to destination, it verifies the whole completion of the data and to confirm whether there is any modifications done in between during transmission of the source and the destination process. So after completion of the packet sending from source to destination, then after that it confirms if there is any modifications from source and destination. After that, it may having some field of changes like hop count, options and also the extension headers. So such kind of hop count means nothing but whereas inside of the packet information there will be some count, that is known as hop count, and also the number of options and number of the extension process. So of this extension process, there will be some kind of fields cannot be protected. At the time, the authentication header should be protected. So it cannot protect every field of the IP header. So and also provides the protection of the fields, and also it cannot be protect every field of the IP header. Let us see what is the format of the authentication header. Here there will be a MAC address, means MAC header, and information of the header of internet protocols such as IPv4 and IPv6 protocols. And here there will be a main of authentication header and there will be a payload. So of this four contains next bit head of 8 bits and payload length of the 8 bits, and also after completion of the result they will get an 8 plus 8 16 bits. Of the 16 bits, there will be a parameter index of security consist of 32 bits, as well as the sequence number and also the authentication data consist of 32 bits. So we can discuss one by one what is meant by next header, what is meant by payload length, and what are this reserved 16 bits, and what are the security parameter indexes, and what are those sequence numbers, and what are those authentication data. So of this all consistent, they are consist of 8 bits. There will be a particular fixed bits of the data. So let us see what is meant by the next header. Next header means it also contains the 8-bit process and it presents after authentication header process. So in case of this, we can TCP and UDP, wireless and wireless, wire and wireless collections we can also use in the next header format, and destination header or some extensions will be happen. So of these extensions will be happen, there will be some of the protocol numbers like IPv4 and also IPv6 protocols. The next one is payload length. So what will happen in the payload length? So previous slide we have seen with the next header format of it consists of 8 bits, and in this slide we are going to see about the payload length. So payload length, it also consists of 8, that is nothing but a use scaling factor of 4, whatever we are having the size of header, divide it by 4 and then subtract by 2. So we are not counting of first 8 bits of the authentication header. First we use the scaling factor of 4 and then subtract by 2. So we are subtracting by 2, so not using at a time of 8 bits of the authentication header. Like this we are going to divide the payload length. The next one is reserved process. So what is meant by the reserved process, which is always set to the 0. So this consists of a 16 bit. So already we have seen here of next bit of 8 bits and payload length of the 8 bits. So of this whole both consist of reserved, this is the 16 bits. So always the 16 bits field which is consists to the 0 by the sender. The next one is security parameter index, that is nothing but a SPI. So basically this SPI arbitrary of the field is fixed is 32 bit. This 32 bit, which is very important field, all identifies all packets should be counts to the present connection. So it also sending, for example, if we are sending data from source A to destination B, they all already know the algorithm they are going to be used. So they are used as an authentication and also the hashing function, and also the key will be there. Only the source and destination. The source and destination will use the authentication process and hashing function and also the key. So here there will be a secret key between the A and B, means source to destination. So this is an exchange method of example of Diffie-Hellman algorithm. So next one is sequence number. So in this sequence number also we are using the unsigned bit of 32-bit field. So it contains mainly any counter values that increases one by one for each packet sent. So whatever they are going to be sent by the packet 1, the value should be increases. And every packet will need some of the sequence numbers. So it will start the range from 0 until 2 power 32 minus 1. So there will be no wrap around of these values. It is really fixed from 0 to until 2 power 32 minus 1. This is the sequence number consists of the 32 bits. The next one is authentication data. What will happen in this authentication data? Authentication data, basically it is an integrity check value. So basically it is a variable length field that contains check values for the packets. So mainly we are using the how authentication will main work. So it basically works about the integrity check values. The integrity check values is nothing but an variable length field. So by using this hashing algorithm and also the secret key, the sender can create message digest which sent to be the receiver. So already message was sent from the source A to destination of the B, so which will be sent to the receiver. On the other hand, we'll use the same of the hashing algorithm and also the secret key. So after the sending to the receiver will also use the same hashing algorithm and also the same secret key. If both the digest messages are equal means if matches, then we'll accept the data. If the message does not matches, it does not accept any data. So here, how the authentication header should be worked. So already we have seen in the previous slide, so from source to destination B, they are consist of number of packets, and also how the message is going to be sent between A and B, and also how we are using the hashing algorithm, and also how we are using the secret key. Here we are going to see how authentication header should be work. So when the packet is sent from A to destination B, it includes both the data and also the header process. If any modifications is occurred during the transmission process, it verifies the origin of the data. Then it later checks and it also any modifies. So for example, if we also note that some of the IP headers, such as we have seen in the previous slide, is hop count and extension headers may also change in transit and not protected by the authentication header. So basically authentication header works by the some IP header fields, hop count, options, and also the extension headers. It should not be protected any by the authentication header. And also focuses on protecting essential fields within the IP header only. Internet protocol header only will focuses and also the protects the authenticating header. So there are some modes of operations which are performed in the authentication header, that is authentication header transport mode and authentication header tunnel mode. So what will this kinds of modes operates? So let us see first one, that is the transport mode. In transport mode, it lies between our original IP header and IP packets original TCP header. That is the transmission control protocol lies between the original IP and also the IP packets. That is the original TCP header and original IP header. It lies between only the two, that is nothing but an original IP header and the IP packets of original. The next one is tunnel mode. What is this tunnel mode will happens? In authentication header, tunnel mode basically origins the IP packet is authenticated. It checks whether it will be authenticated or not. So after this authentication header is completed, it should be inserted between the original IP header and also the new outer of the IP header packet. So whenever the inner IP packet contains the ultimate source IP addresses and also destination of the IP addresses, it consists of mainly source and the destination. So these are the source and destination of the IP addresses. It consists of both IP addresses. Whenever the outer IP header contains different IP addresses, it may fall some of the firewalls or other security gateways. So firewalls is nothing but the types of network IP addresses. It contains basically on any firewalls or any gateways. It consists of firewalls or any other security purposes which consist in the modes of operations of authentication header. So in this today's session, we have discussed what the type of the authentication header, how it is going to be work, and what are their modes of transmission. In the next session, we will discuss the encapsulating security payload services. Thank you.